This is section 2.4, Fitting Linear Models to Data. So we're going to talk about scatter plots today, and a scatter plot is just a bunch of points on a graph that represent data. A line of best fit is a line that fits the data pretty well, and we use it to predict other values. Interpolation is using a line of best fit to predict a value inside of a given domain, and extrapolation is using the line of best fit to predict a value outside of the domain. So we can see here in this graph, if we try to find things in between data plots or data points, it's called interpolation, and anything outside of those are extrapolation. So to find a line of best fit, we can use our graphing calculator. So we want to click on y equals and make sure that all of the equations are cleared. And we want to make sure that plot 1 is highlighted in red on this app. And then right over here underneath the delete button, we're going to hit stat and edit. And we're going to enter in all of our x values in column L1 and our y values in L2. If you hit graph and you adjust your window, you should be able to see your scatter plot there. And if you need to adjust it, go to the window button. You can do an xmin, xmax, and such. So I'm going to just quit out of this for a second. And then if you go to stat, and then over on top we have calc, there's a linear regression, ax plus b. You could use either one. I guess I would just use the ax plus b. And if you click on that, it's going to give you your line of best fit. So, correlation coefficient, so you're going to get a value that's r. It's labeled r when you do that. It tells us how accurate our line is. The closer it is to 1 or -1, the more accurate your equation is. Just notice that the only difference between +1 and -1 is if it's +1, you have an upward trend, -1, you have a downward trend. So some examples of correlations. So notice over here, starting over here, we have them pretty close to a line, okay, if not an exact line. That has a correlation of 1. Notice the more nonlinear we get, the closer to 0 our value gets. And then over here we have -1 because it's a downward sloping line. All of these on the bottom are examples of correlations of 0 because they do not in any way, shape, or form resemble a line. So let's look at an example. So gasoline consumption in the U.S. has been steadily increasing. Consumption data from 1994 to 2004 is shown. Find a linear regression line and predict the consumption in 2008. So we have a table. So we're going to go to stat and then edit. I have already put in all the values here. So I'm going to click stat, calc, and I'm going to go to number 4. And go ahead and just enter through. You get an A value and a B value that you can plug in for your equation to get y equals 2.209, I'm going to go 1x minus 4291.6091. Okay, so this is the equation of our regression line. Notice that r over here is 0.9965, which means it's pretty close to 1, so we should have a pretty accurate line, and I will show you how to test that in a second. So let's go to y equals, and in that first one I'm going to type in the equation 2.2091 x minus 4291.6091, and I'm going to go to graph, and now it shows me my regression line on top of my data, which as our R value showed, it's pretty close. When doing your regression lines, 4 decimal places should be enough to give you a pretty accurate reading. If you need any help on how to use a graphing calculator, go ahead and find on YouTube. There are plenty of resources how to use a graphing calculator. Normally in class we would be using the TI-84 Plus, but this app also works as well.